Let's take a look at question number 45, which references a slope field, which is something you've probably never seen before, and it was my error for not showing it to you on Friday. So to start off with, problem is dy dx equals 2x, and the negative 2 is what we went over in class. That's your initial condition that allows you to actually solve the differential equation. We can do that, obviously, but what a slope field does is give you a visual representation of the solution. It'll give you, first of all, the general solution with all of the possible values for c, and then we will draw in the specific or particular solution through the point negative 2. So a slope field is basically what it sounds like. I'm going to start off by doing a chart with x and y and dy dx. So when x is 0, there's nothing for us to plug in for y, so really our y values don't matter. They can be all real numbers, anything. So the only thing that's going to impact our slope is our x value. So when x is 0, the slope is 0. When x is 1, the slope is 2. When x is negative 1, the slope is negative 2. And let's go ahead and put a 2, or maybe let's go 3. So then the slope is 6, and negative 3, the slope is negative 6. So what I'm going to come over here and do is that all the points when x is 0, and again, it doesn't matter what y is, all the slopes are 0. So I'm going to come in here and go, you just draw the little slopes in. So at 0, 0, the slope is 0. At 0, 1, 0, 2, 0, 3, 0, 4. We can also come down here with negatives if we want to. So that's sort of what the slopes would look like when x is 0. When x is 1, again, it doesn't matter what y is, so I'm going to do them up and down in a parallel method. The slopes are 2. I've always joked that I don't have like a slopeometer or a slopometer, so I'm not going to come out at you and go, oh, that doesn't look like 2, that looks like 3. So I'm going to come in here, and that's going to be what I consider to be 2, and I'm going to draw all these slopes of 2, trying to make them as parallel as I can to one another. Negative 2 then should come over here, and I should be able to do something similar like this. So again, you can see that the slope is not dependent upon y because all the y values produce the same slope. However, the slope is dependent upon the x value. If I go out here to 2 or to 3, the slopes are just going to start getting steeper. So here at 3, I'm trying to draw something that looks a little bit steeper than what I had at 1. So those are all what those look like over here. And so really, whenever I ask you to do a slope field by hand, I'm going to give you some dot paper. It will never be quite this many. I'm going to try to draw something in at 2 that's a little bit steeper than 1, and that's kind of hard to do. They all sort of look the same after a while. So that's a slope field that we've built in. Now, if we draw the solution through the point negative 2, 2. So I'm going to come down here and go to the point negative 2, negative 2. So 1, 2. And from there, I'm going to try to draw something to where all of these would be tangent to the curve. So I'm going to come in here like this, maybe kind of come through here, and voila. That's what my solution looks like. You sort of use the slope to the left and to the right to guide you where to go left and right. In solving this, let's see if this looks right. So if dy dx equals x squared, the antiderivative of 2x is x squared, I think I said that, plus c. So that is y. If we put in the initial condition negative 2, we get negative 2 equals 4 plus c. C is negative 6. And so the solution is y equals x squared minus 6. And I didn't come quite down far enough, did I? I should have had something that looked a little bit more, let's see, 1, 2, 3, 4, 5, 6, where my slopes would look a little bit more like this. Ugh, that's awful. All right, now calculator, because this did actually tell you to do this in your calculator. So I've brought up a graph page. And I'm going to go to menu, and on menu I'm going to go to graph entry edit, and you should have something on there, differential equation, and we have y1, and this little dot right here is prime. It doesn't look like it. Right there we're going to type in 2x. Okay, and then there's our initial condition. And that's -2, -2. So the first thing it's going to do is it's going to draw the slope field for you just like I did. And then it's going to draw the solution through. And we may have to adjust the window. We'll see. So let's hit enter and see what this does for it. Oh, isn't that beautiful? It did it. So there's the slope field drawn in. You can see as you go to the left and right in your x's, your slopes get steeper. They don't really have all of the little slopes in at 0, 0, but that would be your -6, 0, which is what I didn't draw very well. And hopefully this gives you a little taste of what a slope field looks like.